Now it's time to take a look at circles. And we're going to look at everything I can think of on circles and ellipses and arcs or fractions of a circle. All of these things are very, very common on the ACT. And so I want us to take a look at starting with the beginning. The most important thing to remember is your formulas. Your formula for the area of a circle is pi r squared. Now, almost every time I see this given on the ACT test, what the ACT will do is give you the diameter of the circle, and you have to remember to divide it by 2 to get the radius and then square that. They will have both answers on the test. If I had a simple circle equation and they told me that I had a radius of 4, if they told me I had a diameter of 6 and asked me for the area, I will have 6 pi as an answer choice, and I will have 9 pi as an answer choice. Of course, 9 pi is right because we take the 6 divided by 2, we get 3. 3 squared is 9. That gives us 9 pi. You'll get to work through a bunch of these in just a few minutes. Secondly is the circumference of a circle. Think of a circumference as the trip around it. The easy way to think of it, if you're going to build a fence around a circular area, it is going to be the circumference or the perimeter. The ACT loves to use these two words interchangeably. And the formula for the circumference of a circle is 2 pi times the radius, or pi times the diameter. Pi times the diameter. And sometimes the ACT will mix it up. They may give us something like this. They may have a simple problem that says the area of the following circle is 16 pi. What is the circumference? So remember that this is pi r squared. That tells me that, of course, the pi is going to cancel on both sides. And I get r squared equals 16, so the radius is equal to 4. Now, knowing that the radius is equal to 4, I know that the circumference is 2 pi times the radius, which is going to be 8 pi. You want to be careful, make sure you do these right. So, this is the first set of problems we're going to look at are going to be some variation of this. Now we're going to also see that the ACT likes to use the word tangent as it relates to a circle. So let's see what that's actually telling us, because it gives us a piece of important information. When we have a line that is tangent to a circle, that means it touches the circle at only one point, and it makes a right angle with a line that goes through the center of the circle. Now, this right angle is important because many times we have problems where we're calculating an angle. Maybe they've got a triangle in here like this, and they're asking you what's the measure of this angle. Well, they give you a way on this side to figure out what this angle is, and then you would remember that this angle and this angle would have to be equal. So let's put some numbers in and see what this works like. The problem that I'm thinking of, the ACT's had, is this would be 145 degrees. And they start out without giving me this as a right angle like this, and they ask me for this angle. That's the one that we're looking for. But they told me that the line was tangent at this point. So that automatically tells me this is a 90-degree angle. I know that if this is a 145-degree line, and they've told me these two lines are parallel to each other, that tells me that if this angle is 145, then this angle has to be 145. Which means since this is a straight line, this angle has to be 180 minus 145, which makes it 35. So if this angle is 35 inside here, that is a 90 because of what they told me with the tangent. That tells me this angle has to be 180 minus 90 minus 35, which is going to be 55 degrees. Okay, so I want you to have a little bit of an idea about this. Now what we're going to do is we'll take a look at a couple of these problems, and I'll go ahead and walk you through the first couple, and then we'll let you do the next several on your own. So with that, let's go ahead and get started looking at the first problem. Now, you should have these printed out. That's underneath the video. There's a little link that says print this out to work through the video. You need to go ahead and print that out so you can be working along with us as we go through these problems. As we look at our first problem, we notice the words that they use, and we want to make sure we understand what they're telling us. It says in the figure below, all 9 circles are congruent, and each circle is tangent to the circle adjacent to it. And each circle, except the middle circle, is tangent to at least one side of the square. The circumference of each circle is 16 pi. What is the length in centimeters of each side of the square? So let's take a look at this. This tells me that my circumference of that circle is 16 pi. So if you remember, circumference is equal to pi times the diameter. Therefore, 16 pi equals pi d tells me that my diameter is 16. So that tells me this is 16 from here to here. The fact that they told me it's tangent to means it's touching at exactly one point. So they are touching. There's no hidden air gap in between them or anything like that. So that means that's a 16, this is 16, and this is 16, which makes the side length 48 in this problem, making A the answer to 53. Now we'll take a look at number 60. This is one that gives you an example of number 60. This one says, what is the ratio of the diameter to the circumference of a circle? Okay, so we know that circumference is equal to pi times the diameter. Well, they want the ratio of the diameter to the circumference. So we're going to set it up this way. We're going to divide both sides by pi, and that moves the pi over to here. So now we know that d is equal to circumference divided by pi. Now we've got to get it as a ratio of the diameter to the circumference. That means now we're going to multiply both sides by 1 over the circumference, or divide by the circumference, whichever way you want to do it. And that means 1 over pi is equal to the ratio of diameter divided by circumference, making the answer G. Okay, now hopefully you're off to a good start on this. You have 7 more circle questions. So now what we're going to do is give you about 5 to 6 minutes to work on this. We'll just make it 6 minutes and give you an even number to work on. And in about 6 minutes, I will start and explain them one by one through the other 7. So go ahead and get started now. 6 minutes and go. Okay, now that you've had a chance to do that, let's go ahead and work through some of these. If the circumference of a circle is 96 pi centimeters, what is the radius of the circle? So again, we remember circumference is equal to 2 pi times the radius. This time they're using radius instead of diameter. So we now know that the circumference is 96 pi is equal to 2 pi times the radius. Well, we know now that the pi's can cancel, and I get 96 is equal to 2 times my radius. Divide both sides by 2, and my radius is equal to 48, and that makes the answer C to this one. Okay, now let's go on to the next one. This one says the figure below shows the circular garden surrounded by a circular drive. The outside circle of the drive has a diameter of 100 meters. The drive has a uniform width of 12 meters. Which of the following is closest to the area of the garden? Okay, this one requires us to do two things. First of all, we need to remember we're going to be getting area, so we need the radius. The radius to this outer circle is 50, half of the 100. Now we look at this and say, well, if this is 50 and this distance is 12, then the distance from here to here must be 50 minus 12, which leaves me 38. So now we come back to our area equation. Area is equal to pi r squared. My radius is 38, so my area is equal to pi times 38 squared. So we'll take 38 squared times pi, and that's going to give me about 4,534, which is closest to 4,500, making H the answer to number 40. This next one we're going to look at, they've got this picture up above that we're going to be going by, and they have the question down here. And since you've already looked at this, I won't go over that reading the question again. But number 54 says, which of the following is closest to the area in square miles of the region of coverage of the radio signal? So we look up here and we notice that our radius is equal to 52. So this one, my area is just 52 squared pi, which is equal to, when you multiply this out, you're going to get 8,490 roughly, which gets you an answer closest to 8,500, making J the answer to this one. Uses the same picture. Number 35, an 8-foot square sheet of tin from which 4 identical circles are cut is shown below. Each circle is tangent to the other circles and tangent to the other two to the edges of the square. What is the approximate area in square feet of the remaining 10 after we cut these circles out? So this is another circle area problem. We're going to start right here. We need the radius. Well, we know if it's 8 across this entire side, then it must be 4 for the diameter of one circle, making the radius 2. And this one would have a radius of 2, and this would have a radius of 2, as would this one. So now we're going to do pi r squared for our area, which is going to give me 2 squared is 4 pi. Now I'll take the 4 pi, and I have 4 of them. So I'm cutting out 16 pi of the 10. So I have to look at what is the area of the whole thing. 8 times 8 is 64. That's my whole area of the square. Minus the 16 pi is going to give me, if I take the 16 times pi, I will get 50.24. And when I subtract that from 64, I'm going to get about 13.7, which makes D the answer to 35. 48. Let's look at another shape inside of a circle. In the circle below, O is the center. Chord AB is 12 inches long and is 8 inches from O. What is the area in square inches of the circle? Now, a couple of little things to know. When I tell you that this is a right angle, that tells you that it is cutting this line in half. And so we can draw a line from here to here, which is the radius of the circle. And that means we cut this 12 in half, making this a 6. So now what we have is a 6, 8, 10 triangle, or you could do a squared plus b squared equals c squared. And that way we would have 8 squared plus 6 squared equals c squared, which is going to be 64 plus 36 is equal to 100 is equal to c squared, therefore c equals 10. That's the way to do it. Or you remember it's a 3, 4, 5 doubled. 3 doubles to 6, 4 doubles to 8, and 5 is doubled to 10. So what they ask us for is what is the area of the circle. I needed the radius, pi r squared. I know the radius is that, so it's going to equal 100 pi, and that's all we had to do in this one, making j the answer to 48. 52. In the figure below, AB is equal to BC, and AC is the diameter of the circle, having a length of 4 centimeters. What is the area of the triangle? Okay, this one isn't really as much of a circle problem as it is using circle information to solve a triangle problem. They have asked us for the area of the triangle. Remember, when you're going to get the area of a triangle, the formula is 1/2 base times height. I need the base, which they tell me up here is going to be 4. I also need the height, which they didn't tell me, but what they told me when they said this is 4, they told me that the radius of the circle is equal to 2. So this would be 2 as well. So now my formula is just going to be 1/2 of 4 times 2. 4 times 2 is 8. Half of that is 4, making the answer G to 52. 57. In the diagram below, the chord EF is parallel to the diameter AB. And then it tells us the length of EF is 10 inches long and the length of AB is 14. What is the distance in inches from C to the center of the circle? Okay, so we're locating, which is the center of the circle, to D, which is at the midpoint of EF. So they want this distance here where they got the question mark. And what we're going to do is recognize this is 14 inches down here, which tells me that distance is 7. It also tells me that if I make this into a triangle from here to here, that this distance is 7. This is 10, which makes this distance 5. Now I've got a Pythagorean theorem. A squared plus 5 squared equals 7 squared. And when I look at this, I'm going to have a squared plus 25 is equal to 49. Subtract 25 from 49, and I get 24. So I know that a squared equals 24. Well, what we're going to do now is break that down. A squared is equal to the square root of 6 times 4. Now I can break that into the square root of 4 times the square root of 6, which is going to give me 2 square roots of 6 and make C the answer to number 57. Now that takes care of this part of looking at circles. Our next part we're going to move into is the circle equation. Okay, now we've had a chance to look at that. We're going to move up to the next level of looking at our circles. And this is the circle equation. So I'm going to start with the basics here, and then we're going to get to work through a bunch of problems on circle equations. Here's how the basics start. If I take a circle centered at the origin, at 0, 0, okay, that's its center. The equation of this circle is x squared plus y squared equals radius squared. Equals radius squared. This is the way it always is on the test, so don't forget that, equals radius squared. Now, if I happen to move the circle out from the origin, let's say we put it up here and the center on it is at 4, 3. 4 on x, 3 on y. What we get is a new equation that's going to be x minus 4 squared plus y minus 3 squared is still equal to radius squared. It's always equal to radius squared. Don't forget that. Notice that we flipped the signs. I had a positive x and a positive y, but in the equation it becomes minus 4 minus 3. The easiest way for me to keep up with this when I was going through school was I pictured it as if, what have I got to do to move this circle back to the origin? I have to go minus 4 on x, and I am going to have to go minus 3 on y. And that's what we put in the equation. Likewise, if we did one, and let's just say we took this one and centered it right here at minus 5, 0. It has no offset on the y-axis. So this equation would be x plus 5 squared plus y squared still equals radius squared. Okay? So I wanted you to see a few of these, and now we're going to take a look, and I'll do the first problem for you just to get you started, and then I want you to do the rest of these circle equation problems, and then we'll go over them once you've had a chance to look at them. So let's go ahead and get started, and I'll get you off to a good start on that first one, and then we'll let you take it from there. Let's go ahead and look at this first one. A particular circle in the standard xy coordinate plane has the equation of x minus 5 squared plus y squared equals 38. Well, let's notice the first thing. One of the things that I like to look at first is my radius squared. So if radius squared is equal to 38, that means the radius is equal to the square root of 38. With that, I go over and I can quickly rule out 3 of the answers because the answer is not the square root of 38. Remember what we said when we looked at the equation for a circle. If it's a minus in here, that means it's positive over here. So this circle would actually be centered right here. And that would make the equation, that would make the center of the circle at a positive 5, 0 on y. And that gives us the answer F for 36. And that's how there is to really solving these. We'll do one more, and then I'm going to let you do some. As we look at the next one, this is the one that's the follow-up to the one we looked at earlier. And it tells us about this signal and a radio transmitter and so forth. And they tell us it's got a radius of 52 miles. But what they've really come down to is they ask us this question. Which of the following is an equation of the circle shown on the map? Remember, it is x squared plus y squared is equal to, and you see that is not radius squared. So it has to be E x squared plus y squared equals radius squared. Okay, so you should have about 4 problems left. We'll give you about 5 minutes, and then I'll go over each of those. Now let's look at number 53. Once again, we're going to do just like we did a minute ago, and it says, and it has its center at 2, 6. That's a positive 2, which means we're going to have an x minus 2 squared. It's a positive 6, which means it's going to be a y minus 6, and it has an area of 4 pi. So we're like, well, I need radius squared. What is my radius squared? So if it's got an area of this, we have to start and say area is equal to pi r squared. So if my area is 4 pi and it's equal to pi r squared, the pi's cancel and I get r squared equals 4. So I'm looking at the ones that have an r squared, equal radius squared, which is 4. So now I need the one that looks like this, and that's going to make, as we look at this one has the x is the 2, so it's going to be D for the answer to 53. Number 39 in this one says, a circle in a standard xy coordinate plane has the center at 11, -9, and a radius of 8 coordinate units. Which of the following is the equation of that circle? So remember, the first thing I'm going to do is look at this, and it says 8. I'm looking for my 64, so I've cut my answers down to 2 just that quick. Now I look at this, and I see this is a positive 11, therefore it must be negative in the equation. This is a -9, it must be positive, making E the answer to 39. We'll look at 42. It says a circle in a standard xy coordinate plane has the center at 7, -6, and a radius of 10 coordinate units. You should be getting pretty good at this. We scratch these 3 out. We're down to these 2. If I have a positive 7, it must be -7, making J the answer to 42. Now we're going to slow down just a little bit. The others were more straightforward. This one, the ACT, changes things up a little bit. So let me show you what this one is. Remember, if we took this circle and it was centered at 4, 3, and let's say that the radius was 2, this equation would be x minus 4 squared plus y minus 3 squared is equal to 4. Well, that doesn't help us in this at this point, but let's go one step further. What if we FOIL this out and we have x squared minus 8x plus 16 plus y squared minus 6y plus 9 equals 4. Now we're going to get our terms together, and we'll have an x squared minus 8x plus y squared minus 6y. I add the 16 and the 9, and I get 25. Then I subtract the 4, and I get a plus 21 is equal to 0. This is what the ACT has given us. They've given us an equation like this, and what you want to notice is this middle term right here that we got by FOILing it out, that is going to have to be this -4 doubled. All right, and then the third term is always that number squared. So when we look at this -4, we get a -8x. So I do the same thing up here. I have a -6. I'm looking for that to be a positive 3 for the x coordinate of the center of the circle. I have a 4y, which means I'm going to have a minus 2 in the equation. If I worked this backwards, I would have had, to get this, I had an x minus 3 squared plus y minus 2 squared equals, and we'll go over that part in just a minute, but all we really needed was enough to get the answer right. If I have a positive 4 here, it must have been negative. So that would give me a plus right here and make it, if I FOIL this out, I'm going to get the y squared plus 4y, and then I would get a plus 4 here. I'm going to have a plus 9 here, and that equals 13. So what that tells me is the radius of the circle must have been 1, because when you do the math, that's how it's going to turn out. I would have subtracted the 1 just like I did over here with the 4, and that would have got it. I'm just giving you a little bit more information. It's more than you actually need to solve the problem. But I'll just go ahead and spread that out just to show you. If I had done it this way and I'd had an x minus 3 squared plus y plus 2 squared equals 1. Now I would have had an x squared minus 6x plus 9 plus y squared plus 4y plus 4 equals 1. So now I'm going to have an x squared minus 6x plus y squared plus 4y. This 9 and 4 gives me 13. Subtract the 1 gives me a plus 12 equals 0. That is exactly what we started with. So it tells us that the answer has to be J for this one. Hopefully we're getting a little better at understanding these circles on the ACT. But now we're fixing to change gears again. And we're going to look at circles just a little differently. This is going to be looking at the circles and the arcs. How does an arc fit in? And some of the next set of problems you've got are going to be looking at that, as well as some other issues of circles that we'll go over as we get to those. But I wanted to give you a little bit of the basics first. Very typical problem on the ACT. They may tell you that the radius of this circle is 12 feet. Then they're telling you that our angle theta is 60 degrees. And they ask you, what is this arc length out here? So here's what we want to do. First of all, remember that your arc length is a fraction of the circle's circumference. So remember that the full circumference is equal to 2 pi times the radius. Well, a circle also has 360 degrees. So we're going to look at this as what I've got is to the whole as what I've got is to the whole, depending on how we split this up. So the first thing I need is my circumference. I have a radius of 12, so my circumference is equal to 2 times 12 times pi, which is equal to 24 pi. Now, I know that this is a 60-degree angle. So what I'm going to do to get arc length is I'm going to say 60 degrees is to 360, as x, the arc length that I need, is to my total circumference, 24 pi. Now, a little shortcut that I like to do is if I can reduce a fraction, I do. And so 60 goes into 360 6 times. So I can say that goes 1, and this is a 6. So now when I cross multiply, I get 6x equals 24 pi. X is equal to 4 pi. So this arc length is 4 pi long, and that's how you do these. Now let's take a look at another kind. The ACT has had problems where they will give you the percents. Maybe it's a budget. They're saying a family has a budget and this much was for their mortgage payment, this was car payment, this was food, this was entertainment, this was savings, or some combination like that. And they're asking you, if you made a circle graph of the budget and you wanted to look at the 40% sector, how big would it be? What would be the degree measure of that percent of the circle? So remember that it takes 100% to make a whole. I have 40%. 40% is to 100% as x is to 360. So now I can reduce this fraction. That gives me 4 over 10, which reduces to 2 over 5. So now I get 5x equals 720. Now we're going to divide 5 into 720, and that gives us 145 degrees. So that angle would look like this and be 145 degrees, and it would equal the 40%. And that's how we would do these. All of these are going to work out to be that you take what you've got to what it takes to make a whole in that category is equal to what you've got to what it takes to make a whole in the other category. Whether you want the circumference or whether you're wanting the angle or whatever you're wanting, that's the way this works. Now, we're going to take a few minutes. We're going to work through some of these next problems, and I'll get you started with the first couple of them, and then I'm going to let you take it from there. So let's get started looking at the next set of circle problems. Now what we want to do is take about 8 minutes to work through these next 11 problems, and then I'll come back and go over each one of these one at a time. So go ahead now and take 8 minutes, and let's see how you do. Okay, now we're going to look at this one, and it tells us that these chords, TR and QS, intersect at P, which is the center of the circle, and the measure of PST is 30 degrees. What is the measure of the minor arc of this, RS, out here? So let's sort of take this apart. First of all, when I have these lines inside, this is a radius and this leg is a radius, which tells me they are equal. And in a triangle, when the opposite sides are equal, that means the angles are equal as well. So that would be 30 and this would be 30. Now, we know that 180 minus 60 is equal to 120. So this angle has to be 120, which makes this angle 60 degrees. And the rule is that if the central angle is 60 degrees, then the arc length is 60 degrees as well, making H the answer to 48. We look at the next one. This is a little bit different because it tells us that we've got this 0.66 on the circle. It has a center of 2, 3, and it has a radius of 5. What are the coordinates of the image of P after the circle has been rotated 90 degrees? Okay, so what we want to do is look at this, and this is going to come in where we'll just draw ourselves a line here to get an idea of what that looks like. And then we're going to draw one that would be roughly right angle to that, which is something like this. Now, you can do this on the test. If you're in a hurry and you're looking at this, you can say, oh, it's right here. How many answers are close to that? There's only one. 5, -1 is the closest one that you possibly have. Now, if you're not sure about that, let's look at it another way. Okay? What we want to do is look at this as a line equation. And this line is going on X from 2 to 6, which gives me a 4. It's going up from a 3 to a 6, which is a 3, which tells me my slope is equal to 3/4. Now, if I'm going to draw a line that's perpendicular, it's going to have a slope that is equal to the negative inverse, or it will be -4/3. Now, -4/3 means that I'm going to go down 4. So if my y value is at a 3, and I go down 4 from here, I'm going to be at a -1. And then I'm going 3 over on the x-axis. And if I'm at a 2 and I go over 3, I'm going over to a 5, -1, which is the answer. So the answer is C for 37. On our next one, it tells us in the standard XY coordinate plane below, a circle has a radius of r coordinate units, and it passes through the origin O. The circle has a diameter of OS, where S lies on the negative y-axis. In terms of r, what are the coordinates of S? Okay, well, remember that the radius would be here. That would be 1r. This is 2 r's, and it's negative. So the coordinate, of course, would be a 0 on the x-axis and a -2r on the y-axis, making G the answer to 38. And this next one, 14. In the figure below, lines L and M are tangent to the circle at these points respectively. Points A and C are on the circle. The measure of angle ABC is equal to 95 and BCD is 85. Which of the lines in which of the following pairs of lines are necessarily parallel? This really is not as much a circle problem as it is understanding our parallel lines. If I take two lines like this and draw a line through them, this is called a transversal. This line tells me this angle plus this angle has to be 180. What we usually remember in math on geometry is that alternate interior angles are equal. So we know this angle equals this one. But remember, if that angle equals that one, then this angle plus this angle has to be 180. But also this angle and this angle are going to be equal. So that means this one plus this one is 180. Well, if two lines like these two CD and AB, if the angle between them, the sum of the angles, 85 and 95 is 180, then the two lines are parallel. So let's look at it again like this. If two lines are parallel, then these angles are supplementary, which means they total 180. The converse is also true. If I have two lines that have a single transversal between them and the angle, these two angles add up to 180, then the lines are parallel. So what that tells me is the answer has to be AB and DC. Now the others are not. We don't know what their measure is, but they can't equal what these two. We do know what the angles are, and that tells us that the answer has to be G2 only. What is the degree measure of an angle that measures 5 pi over 12? This, again, is not as much about a circle problem as it is just converting an angle from radians to degrees. Well, remember that 5 pi over 12. The conversion factor is pi radians is equal to 180 degrees. Remember that because the ACT's asked that before. If they ask you how many radians are there in a square, well, there's 360 degrees in a square. And so that would be 360 divided by 180 would be 2 pi radians in a square. So in this case, all we have to do is substitute this 180 for the pi, and I get 5 times 180 divided by 12. Well, 12 goes into 180 15 times and makes the answer 75 degrees, or G. Number 60. The circle shown below has a radius of 10 centimeters. A central angle with a measure of 18 degrees intercepts the minor arc AB. How many centimeters long is the minor arc AB? How long is this arc? Remember when we worked through the practice problem of this, I have a radius of 10. From that, I need to get my circumference. My circumference is equal to 2 pi times the radius. So it is equal to 20 pi. That's my circumference. Now what I'm going to do is I need to know what this is. I have 18 degrees, which is my angle here, is to 360 degrees, which is the whole circle, as x is to 20 pi. Now, if you do just a little bit of math, I love doing the crossing outs because that makes it so much quicker. 18 goes into 18 one time, 18 goes into 360 20 times. So with this, I end up with cross multiplying 20x is equal to 20 pi. Cancel out the 20s and I get x equals pi, which makes this pi and the answer H for number 60. 58 is a little bit different kind of problem as well. What they're asking us to do here is to look and figure out what this is, what the length of this is. So let's take a look at what the question asks. The 7 congruent circles shown in the figure below are centered at points A through G, and each circle has a circumference of 24 pi. The 24 pi. Now, points A through F are spaced equally on the circumference, and they are centered at G. What is the sum of the lengths of the 6 thicker arcs that are these 6 arcs I got identified? So that you just look at the ones that's bolded out, and it's this one, plus this one, plus this one, plus this one. So what we've got to do is try and figure out how long these arcs are. Now remember, it tells us all of the circles are congruent. Now that's going to help us a lot because when we look at this, we see that this one big circle has a circumference of 24 pi. And we are dividing it evenly into 1, 2, 3, 4, 5, 6 pieces. So if it is 24 pi, and we've cut it into 6 pieces, each piece is 4 pi, which means this little segment has to be 4 pi, and that's 4 pi. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 pi times 12 is 48 pi, which makes the answer F to 58. Number 30. In the figure below, line Q is parallel to line R. And C is the center of the circle. AE and BD both go through the point C. Q is tangent to the circle at B. And the F lies on AD, and the measure of FAC is 145. What is the measure of BCE? So the first thing we do is we find out where is BCE. You see where the question mark is? It is this angle. So when I look at this, I say, well, when they told me that line Q is tangent to the circle at B, that means it makes a right angle right here. And that would be a right angle over here. So I already know one of my angles is 90 degrees. If I knew this one, I could solve the problem. So I look at this and I recognize, okay, this is 145, told me Q and R are parallel. Q is parallel to R. So that tells me that that 145 is equal to this one, which is 145 as well. Which tells me this angle has to be 35 degrees because that's a straight line. So 35 and 90 is equal to 125. And if I take 180 total degrees in a triangle minus 125, I get 55, making the answer 55, or J, in number 30. 52. A circle in a standard XY coordinate plane is tangent to the x-axis and has its center at 2, -2. Where is the point 0, -2 located? So we're going to draw this out. It has its center at 2, -2, right here. It tells me it's tangent to the x-axis. So this is the x-axis. So what that tells me is it has a radius of 2, which means it would also be touching the y-axis over here at 2 away because I am only 2 over on the x-axis. So it would actually be on the circle, or J. 48. In the figure below, the circle with center O has a radius of 7 inches and a measure of 80 degrees. What is the measure of angle BAO? This is another one of those. Looking at a circle, the distance from here to here is also a radius. So if it has a radius of 7 here, this is 7, which tells me this angle and this angle have to be the same. They told me that my arc length is 80 degrees, which tells me this angle is 80 degrees right here. So now that I know I've got a triangle, I've got 180 degrees minus 80 gives me 100, and these two are even, so I divide by 2, and we get 50 is the measure of each of those angles for 48. 55. In the figure below, the circles centered at P and Q intersect at A and B. The points P, Q, X, Y are collinear, and the lengths of PB, QB, and all these things are 9, 12, and 2 units respectively. What is the length in units of PQ? Now this is kind of an interesting question. It comes back once again to our radius question. You notice that this distance from here to here is 12. It's our radius. And this distance from here to here is 9. Well, if you look at this and you say, well, I'm going from Q all the way to the edge of the circle, that would be 12 as well. And if I'm coming from P to the edge of this circle, that would be 9. So what I have is 12 plus 9 is 21. But notice this little 2 in the middle. I've added it twice. It is part of this 9. It is part of that 12. It's okay to be counted once. It needs to be counted once, but it does not need to be counted twice. So I subtract the 2 out, and we get 19, making D the answer for 55. Hopefully now you feel pretty good about your circles. We're going to twist things around again and take a minute to look at ellipses. Ellipses are sort of squashed circles, if you want to think of it like that. And let me show you the basic formula for an ellipse. An ellipse looks like this, and the coordinate values that you have for an ellipse go like this. As I go out on the x-axis, this distance is A. And that's going to be the A that's underneath my X here in the formula that I'll go over in a minute. My distance up on my Y-axis is B, and B is what's underneath my Y in this formula here. Okay, this is what it takes to describe an ellipse. Now the main equation for ellipses goes like this: X over A squared plus Y over B squared equals 1. That's your equation for looking at an ellipse. So What the ACT almost always does, if they're going to give you one like this, is they will go ahead and square this out, and let's say they'll have an x squared over 4 plus y squared over 9 equals 1. What they're wanting you to realize is that your b was actually 3, and your a is actually 2 in the equation. So if you're looking at this distance and this distance, you can use that information to figure out what they're asking in the problem. I wanted us to take a look at this. Now we're going to look at 3 or 4 of these ellipse problems, and I'll get you started on this first one, and let's see how this goes. You have 3 ellipse problems that we're going to work through, and I'm going to give you 5 minutes to work through these. You get 5 minutes to work on these, then I'll come back and go over them. Okay, now as you remember when we talked about an ellipse before, that I told you that the form of the equation is x over a squared plus y over b squared always equals 1. So right away we've got 3 answers we can take out. Now we're going to look at this one, and this time my value for a has to equal 2. My value for b is 3. So I'm looking for one that's going to have a 2 in the bottom squared. So I'm going to have an x squared over 4 plus y squared over 9 equals 1. And when we look for that, we're going to see that E is the answer to 59. 51. The area of an ellipse centered on the origin is pi times A times B. The lake in the shape of an ellipse has an area of 6 pi square miles. If the lake is 6 miles across at its widest point, then how many miles is it across the shortest point? So what you're looking at is they've told me that A times B times pi is equal to 6 pi. So I've got 6 pi is equal to this. Well, if I know that A is 3, see, it told me the lake is 6 miles long. That means it's 6 miles from here to here, which means it's 3 for A. So I know that it is going to be equal to pi times 3 times B. I don't know what B is yet. So the pi's cancel, and when I divide 6 by 3, I'll get 2 is equal to B, making this value 2 over here. So it wants to know how wide is it. Well, if it's 2 to there, it has to be 2 to here, making it 4 all the way across, or 51. The answer is D. This next one says one of the following graphs in a standard xy coordinate plane is the graph of the equation x squared over 4 plus y squared over 9 equals 1. Now we should remember this because we just saw this problem the other way just a minute ago. Knowing that this is a 4 tells me that my A is a 2, and I'm looking for one that's going to have my A value about halfway to the 4, which pretty well makes E the answer. I could also look for the value to be a little less than the 4 here, which would be a 3 for that and a 2 for that, making E the answer to 55. So hopefully now you have had a little bit of experience with the circles, with arcs, now with a little bit of ellipses, and hopefully you feel much more comfortable about this and can start working on some of the problems. And when you see these circles and the ellipses, you can zoom right through them with confidence. Hopefully this has helped you get off to a good start in understanding circles and ellipses and the way they can show up on the ACT test. Hopefully we've covered enough variations that when you see those problems on the test, they're not going to be exactly like what you've worked, but you're going to know the circles and ellipses well enough to be able to figure it out based on what the ACT gives you. So with that, that'll end the circle and ellipse video. But now look at some of our other videos that we have and see which ones you want to watch next.